I'm going to record the progress of me making cat on a shelf. So this scene here, let me add to it. Let's just scale that out so it's more like a floor, a little wider, and this. And so we have something to be the floor. In the camera, let's just Control-Shift-F. Just tag that as the plane. And I guess since I'll just keep things the same name, I'll call this plane. So we're playing on. And I made a tag. Now let's give that the tag. Okay, good. Now let's make our player object, which will be a cube. Just keep everything simple. Pick them up to be on top of the floor. Let's tag that as the player, and we can name it player. Sorry about that. We'll name it player. All right, the floor is not going to move, static. And here's the cube. So first things first is we have to be able to move the cube. We have to be able to control the cube. So I'm going to select the player, and down here I'm just going to add a new script for the player. I'll call it player. Let's go inside the script. Open up Visual Studio for that. All right, so see, these are grayed out because we're not using them yet, so I'll just take them out, add things as I need them. Now I'm going to require a component. So what this does is it makes sure that whatever I put this on, let me take these out. Whatever I put this on, the script, it's going to have a rigid body, whether it's there or not. But now when I drag the script on there with the require component player, it's going to add the rigid body for me. See, right there. And here we have the script. So go back to the script. It added the rigid body for us. So first things first, let's have a public float that has the move speed of our player. And we'll say that we move at a speed of 3.5. Okay. And now to move around, we're going to have an update function. So private void, and if I start typing update, you can see it right there. It says update is called every frame if the model behavior is enabled. These special functions, these are there because the class player is derived off of model behavior, and update is part of model behavior. So this is going to call every frame of the game. So what we want to do here is read the keyboard for movement. Okay, so I will say if input dot key down or get key. Let's see what we have as the functions for the input class. The input class is from the Unity engine, as you can see right there in the little pop-up, and it's how we get input for our game. So I press the dot, and now I have all the different things available to me from the input class. I could see them in a list. And I know it's called getKey, but if I didn't know, I could look for a function like this one. If it's a purple cube, that's a method. So here's the getKey method. And let's see what parameters it takes. I just typed in the first parenthesis, and it takes a key code. So I could start typing in key code until it appears on the bottom there, and I could just press tab, key code, dot, and which key should be for, I'm going to use the arrow keys. So I'll say up arrow will move me forward. So input get key up arrow equals true. That means I'm pressing the up arrow. Then I will do these commands inside these brackets here. So let's see. My player object is what the script is attached to. So this script is attached to the player game object. So that means if I want to refer to the player game object, I use the word this. Dot transform is the position of the player. It's this part of the player here in the components, the transform. So here's the player, and I want this transform because with the transform I could set the position. You see, if I change the values of X or Z, then the player is going to move. So here in the script, I'm going to say this transform dot translate, and the axis I want it to translate on is the forward, which is Z, positive Z, times the move speed, times time dot delta time. I'm always going to use that time delta time for whatever the speed is, because forward, as you can see in the pop-up, it's a vector 3 of 0, 0, 1. So that's how long the vector is. It's just a unit of 1. Then the move speed, will multiply it by 3.5, so it moves even faster than 1 unit at a time. So let's see, with that script there, and let me save the script. So you could always see if you save the script, it has a little star there. So I could just save the one file by pressing the icon over here or Control S, or I could save all my files that are open and I could press Control Shift S or this icon. So I just pressed that and the icon went away. Now when I go over here to Unity, it's going to have this little hourglass spinny thing. It's reading the script and the script is read. Now if I press play with that simple little script I have, if I press the forward up arrow, I move forward. So cool, I can move in one direction. Now let's just catch the other directions that I'd want to move in. So up is forward, and let's just save some time from typing, and I'll just do Control Paste 4 times because we can move in 4 directions, right? So up arrow, move me forward. Then I'll use the other arrow, which is the down arrow, right? And instead of forward, let's see if they have a back. Dot back, they do. And then up, down. Now I'll do left and right. Let's see if they have a left for the key code. Left, and as you can see as I start typing, there's left arrow. So I could pick it. And let's see if there's a vector 3 left in the left direction, left. And there is right there, left. And then we're going to have right. So I start typing right and I see right arrow. And they had a left, they probably have a right for vector 3, right. All right, so this should be that I can move in all 4 directions. So this is move in all 4 directions. Now, this here that's in the color green, this is a comment, means that it doesn't matter what I type here, the code will still compile. So let me save that. And making this a comment is just because I put these 2 dashes in front of it. So for example, I could turn anything into a comment by just putting 2 dashes, and then the rest of that line becomes a comment. Another thing to notice is like for each of these commands here where I did this translate, I called transform.translate to move the character, and I gave it the parameter of how much to translate. That's a command, and the commands end with a semicolon. That is a dot and a comma. If you zoom in closer, you can see it's a dot and a comma. And the same thing here, when I declared this variable move speed with a public, that is a variable and it ends with a semicolon also. So every time there's a command or a declaration of a variable, you have to end it with a semicolon in this language of C#, okay? And then an if statement could have a bunch of commands. Even though I only have one command at this moment, it could have a bunch of commands. So for an if statement, after the if test, you put these brackets, and then everything inside these brackets goes for the if statement. So anyway, let me press save, and let's see now that I can move in all 4 directions, if I could actually move in all 4 directions over here in the game. So I'll press play, and the game starts up, and I can move in all 4 directions. All right, good. So now I have some control over my player, but probably we want to do a jump. So let's add one more control. So we're using these keys to move around. I'll first put a comment here for, I'm going to do a jump thing. So for the jump, let's say that we press the space bar. So I'm going to say if input.getKey key code dot space, there we go, space bar equals true. Now get key is that the key is currently pressed down, and if the key is down, then this continues to be true. All right, and that's why over here I just had to hold down the up arrow or these arrow keys and my character kept moving. I didn't have to like press the arrow over and over. But let's see what happens over here with jump. I just want to press the key and only jump one time. So instead of get key, there's another function here called dot get key, and you can see there's a down and an up. So when the key first presses down, that's the key down. When I let go of the key, that's the key up. So I'm going to do it on the get key down. When the space key is pressed down, so it'll happen one time, then I want this to be true, and I'll do the jump action. So let's see what I could do for jumping. I'm going to use the rigid body that's added to the player right here, this rigid body. And what I'll do is with the rigid body, I could use physics instead of just moving the character. I could use physics, and I could just add a force like poof that pushes it up. And then gravity, of course, will bring it back down. And to me, that'll be a satisfactory jump. So what I'm going to do over here is I'm going to get a pointer to the rigid body that's on my player game object. And this could be private, so it doesn't show in the inspector window. Private rigid body RB equals null at first. And then I'll make a function. Let me just position my cursor. Private void start. So start is another method that's part of mono behavior. And start is called when I start the game. Update is called as the game is playing, it just gets called over and over. So in start, just one time when the game starts, I want to set my pointer to the rigid body of my game object. So here's the player, here's the rigid body. I want a pointer to this so I could do stuff to it. So this is equal to the game object dot get component rigid body. Okay, so what that's going to do is it's going to look at the player game object and get the component. See, these are components over here in the inspector. I get the rigid body component. Okay, and now I have a pointer to the rigid body. So now when I press play, it starts. Now over here when the game's playing, if I press the space bar, I could say rb dot add. There's different kinds of force. Relative force is related to whichever way my game object is facing, so it's related to me. It's like whatever the top of my head is as a player. I'm going to add a relative force, and the direction I want to add the force in is a vector 3 dot, is there an up? Because I want to jump up. Up. Good. Vector 3 dot up, and there's types of force. See, there's 4 different kinds of calls to this add relative force. This is the first one where I give it the direction of the force up, but let's see what the other one is. It could also take a force mode, so let's use that one. Force mode. What kind of force are we adding? Dot velocity change is the one I want to use. Okay, that it instantly puts a force moving upward. Okay, in the power of 1, because vector 3 up is only equal to, you see that, 1 in the y position. 0, 1, 0, x, y, z. All right, let's see what happens with this. I press save, go back over here, and press play. All right, I can still move around. And if I press the space bar, he barely jumps. I need some more force to add to the jump. Now, let's make that another public variable so it shows in the inspector window. Public float jump force. And let's start off by saying the jump force is 5. Okay, and these little f's mean that it's a float number. So 3 is a whole number, and 0.5 is halfway to 4. 3.5 decimal. And 5.0, it's just the whole number 5 and no piece of a number. And since I want them to be floats, I put an F after the number. Now that I have this variable jump force, let me just copy it and let me use it to multiply the up power times the jump force. That way it's not a 1, but it's whatever 1 times the jump force is. And you'll see I'll be able to jump higher. So I save that, go back here, hourglass spins, and now I press play, and I move around and I press the space bar, and there you go, I could jump. Now here's the benefit of having some of these variables here in the inspector window is I could just change the values right here. I could change this to an 8, and I could see what an 8 will do. Right now I click back in the game window, and I kind of move around, and now I press 8. Now my 8 jump is that high. And I can do the same thing with the move speed. I can either type in the number, or you see I put my mouse over here over the word, and I could change the speed. I can move faster. Let's see, I move at a speed of 6.94. Click back in the game window, and now you can see I can move faster and jump higher without changing the code because the variables are here in the inspector window. Since I did these variable changes when I was pressing play, when I stop, the variables go back. If I want those variables to stay those new values, then I just have to do it when I'm not pressing play, and it will remember those values even when I do press play. Okay, now it's remembering the values 5 and 8. So what happens to these values over here that I said 3.5 and 5? These are just default values. If somebody changes the values in the inspector window and then presses save on the game, it's going to remember 5 and 8. If somebody doesn't use these, change the values, it would have stayed 5 and 6. So say if I put another game object in here, I'll put another cube in here, and let me just move it over and pick it up. See, it doesn't have a rigid body. I'm going to drop the player script, which requires a rigid body, and bam, it has a rigid body. See, the values are 3 and 5. So this one, the values are 5 and 8 because I changed them. And this one, the values are 3 and 5 because that's the default values that I have in the script right there, 3 and 5. All right, so now I got two objects that have the script on them. What happens when I press play? Well, they have a rigid body. They both drop to the ground. And this one moves faster and jumps higher than the other one. Anyway, that's not what I want to do. I'll just delete that. I was just showing how the script works. So now I have a player that I can move around and I could jump. Next thing I'll do is I'll add a script. I'll add an effect so when I jump and I land on the ground, I'll make like a crashing effect. That's going to be really nice looking.